day, everyone. My name is Fortune Odesanya, and this session is just to put to practice a little bit of a task that we've been assigned with as part of the ADA MicroMasters program in data analytics and machine learning. So we assigned a task which has to do with building and deploying a machine learning model for malaria severity prediction. So there are a number of things we needed to do, but before I even go too far, it's important to make it very clear that what we are deploying, what we are talking of now, we're talking of deploying it. Number one is not something that I built. I didn't build the model. I didn't really start. So it's a model that is already built by someone else. So the task here is to be able to take this model, make sense of it first of all, and then build, of course, make sense of the code. Then of course, then proceed to build and then deploy it so that it becomes publicly accessible for other persons to even make use of it. So the first thing is to understand what the model does. That is to predict the severity of malaria. Now, it is not to predict if there is malaria or not. It is assumed that there is malaria based on the data set we provided. So they say it's clinical data set of about 337 malaria patients. However, the job of this model is now to predict if this malaria is severe malaria or not. So based on data that is provided to it, it's able to ascertain, oh, this is severe and this is a mild case of malaria. So the severity is either a low severity, which is possesses little risk, or a medium level or a high level. So basically, what we have on the screen now is just what the steps we need to take to work to achieve the desired goal. So as I did mention, we provided the training, the model, which has already been for training and all of that. So this is just a step-by-step guide which we follow. However, it gets to a particular point which I just want to quickly jump to. After deploying the model, after building and training the model, everything, in getting a web application that allows users to visitors or users, as it were, to go there and fill in necessary information and then go ahead to predict using Streamlit. So let me quickly jump to that session. Okay, building an interactive web app. Okay, so the task here was, okay, we are given a core, a basic what do we call it, a basic a basic UI here, and which has four major components: model for loading, the widget for the input, the prediction logic, and the final result. And we are now given a task to try to extend this UI to make it better than what is currently obtainable, than what we currently have right now. So I am not going to lie. Why did this give a bit of some form of challenge? But I was able to do some level of research to understand the task and then go ahead to try to implement the extensions. So then there are other tasks here that we should do. So I'll just jump right into it. So let's go over. First of all, let's take a look at. So another thing I had to do was, okay, so I needed to have an understanding of I noticed from the training, from the data set, and from everything that was done, there were a number of features, a number of symptoms that I used to identify where that were used in the whole process. So, which include fever, cold, and all of that. So, to have a better understanding of all of this, what I had to do was to take all of these features and then try to understand what each of them mean. So I did a bit of research so I can understand. So I discovered, okay, so based on the features we are provided, there are basically three classes of it, three types of it. You have the basic, which is general malaria symptoms, which is basic for any form of malaria. So we have fever, cold, the rigor. Now, before now, I never understood what rigor actually meant. So it is as a result of this I got to understand what rigor actually stands for. Then the rigor headache, then the bitter tongue. So these are general everyday malaria symptoms. Then you have another category which is gastrointestinal. So this one has to do with things that have to do with your stomach and your intestines area. So those are the gastro. So that's where vomiting and diarrhea comes in. Then you now have the where you have complicated cases. So convulsion comes in, anemia, jaundice, the Coca-Cola urine. In fact, this is also my first time of hearing the term Coca-Cola urine. So I believe these are things that have been that at one point or the other we have experienced, but we never really understood there was a medical term for it and all of that. And then the hypoglycemia, prostration, and the hyperpyrexia. So all of these I had to take my time to understand to say, okay, so I have an understanding of, oh, this is what the criteria for doing the prediction and all of that. Okay, so um, these are from the research I did. I was able to have a bit an understanding of what each of these symptoms represent and how they apply in terms of malaria diagnosis, and subsequently to know uh, where malaria is severe or not. So that is the first thing I did. And then, of course, as I mentioned earlier, we previously have been provided with the uh, the data set. This is the data set, and so for those who may be wondering, I have an extension on my VS Code that allows me to view CSV files in in the tabular structure within my VS Code. By default, a CSV file is basically a text file. So if I were to open it without this extension, it would not really give the desired look. But with this extension, I'm able to get an understanding. I'm able to see the data in a tabular format, and I'm able to understand it better. For those who are wondering, let me quickly you can see this extension here, CSV is one. Let me quickly do a search on my extensions so you can see. So the actual extension I'm using for this actually is Rainbow CSV. So it's a Rainbow CSV. So that allows you to actually view your your CSV. You can also, the CSV works. So no, this particular one is actually using the CSV extension. So it allows you to see your data in a structured format rather than the normal text format it would be. So this was data set we worked with. It has about 17 predictors, where two of them, the first two is age, the sex. So what this one simply means is the sex. For 1 it is male, for 0 it is female. For 1 it is male, 0 is female. Then for the other predictors, about 15, 1, 2, 3, 4, about 15 of them, from fever to hyperpyrexia. When it is 1, it means it is present. When it is 0, it means it is absent. So a person who is, in this case now, the subject 1 is experiencing convulsion, but subject 2 isn't experiencing it. Subject 1 is jaundiced, subject 2 isn't jaundiced. Now, before we even go further, at the point when I was working with it, I ran into issues because I was interested in getting results, but later I had to see the need to truly understand the data. Now you will notice here the header column, the header row. You notice while the vast majority of them have everything in small letters, a few of them have the first letter as capital letter, like convulsion, anemia. Now, it is important to understand that the data we are provided with has been trained with this format. So it is important to always ensure whatever you are going to be doing, anywhere you are going to be making use of all of this, you must maintain the same way it is provided in this data set. The cases must match. And then another thing, there were a few spelling a few places where the spellings were not exact, like in the case of the headache. It's supposed to be headache, but here we are having headaches. Jaundice is supposed to be a JAU and not JU. And then prostration, the C is actually not necessary. I got to know all of this based on the research, especially when I provided when I try to find out the information about all of these symptoms and what they represent. So, however, while we understand all of this, it is important to remember once again, your data has been trained, your model has been trained based on this. So, while trying to do the work, we should always maintain exactly what we have here. Okay, so that is our data set, and then this is the training. This is where the training of the data was actually done. So now it's important to realize something. We can actually go ahead to fix all of these naming errors. What that simply means is this: for us to do that, if we go ahead to make changes in our data set, let's take conversion for example. Let's fix it and make it a small letter. And the headache, let's try to fix the spelling. So rather than headache, it becomes headache. And then let's do something similar for anemia. Coca-Cola urine is okay. Then prostration, let's take off the C so that it becomes prostration and not prostration. So I've made all of these changes. I'll just go ahead to save. Now, if I do this, what this simply means is I must come back here to retrain my model. I must come back here to retrain my model. So how do I make this? For me to retrain my model, it is very simple. But after I retrain, while we are going to do all of that, it is important we now come and take a look at a few areas. Let us take a look at some other files that we have here. Let's take a look at app.py, which is our API entry point. This is our API entry point. So and what we are doing here is to ensure anywhere we have all of those, let's ensure it tallies. Okay, so I'm going to change this to C, small letter C, headache. Oh, I forgot to change jaundice. I think I'll go back and fix that, and then I'll save this. I'll come back to my malaria data set. Jaundice needs to have the letter A here, and so I'll save once again. I can close this. So this has been previously trained. So here's what I'm going to do. I'm going to come here and just run the Python script to retrain our data, py, and let us run again. Okay, so the training is complete, and then you can see the columns now: headache, convulsion, all of these have been updated, prostration, jaundice have been updated. Then the next thing I want to do is to let us execute the app.py, so which is going to rely on this training data. And so the next thing we'll do is Python app.py. So while the train actually trains our model based on the data set that we have made available, app.py allows us, is our API entry point, where we have where we handle requests based on the training, the pipeline, and the training that has been done. And then so you may have issues around this point. All you just need to do is to update this line to the update. So Python, due to due to changes in the syntax, a few updates have been done. So you just need to make a little bit of change to this started at point. And then these are our routes. We have the else, we have the info, which will list out all the features that are necessary. And then we have the predict, and finally we have the stats that shows us, that return the statistics of everything that has been done since the start of the server. Now, I know one more thing I did. I'm running on a Mac, and already there's a particular application that is using the default port 5000 that was provided in the original code. So all I simply needed to do was to update my port to the desired port I want, and I'm using port 3100. So the next thing now is to execute python app.py. Okay, so it has started. So development server. So I'm going to use an app called Postman. So if you're a developer, you would understand, you'll be familiar with Postman by now. So I'm going to use the app called Postman to try to access my API. So this is Postman. I had previously tested everything. So I'm going to come here to API-S and run it again. As long as it returns a result and status 200, it means everything is okay. Now, before I even run this, when I ran information earlier, you'll notice this was a list of the features it gave to me for testing. Notice headache is spelled this way, convulsion with a C, anemia with a capital C, anemia with a capital A, jaundice, the A is missing, and prostraction has the C. So let us try run this again. By the time we run this again, you will notice there is an update. The headache is now fixed. The jaundice is now fixed. Anemia, convulsion are now small letters. Prostration also has been sorted out. Okay, so that is exactly what we did by updating the column headers in our data set, and then retraining our model so that it will work with the updated data set. So the next thing I'll come to is the prediction. So if you are not familiar with working with APIs, you may have a bit of issues. Now there are there are other kinds. There are actually about 4 kinds of API methods. But for our case, we are working with the get and the post. Now, let me just quickly say a quick difference between the get and the post. Now, the get, when I ran this, you can see here shows get. I did not provide any data to it. I did not feed any information. I did not provide any data to it. I just want to see a feedback. And so I'm using the get method. The same thing applies when I did information. I did not provide any data, so I'm using the get method. But in the case of the prediction, I will need to provide data to our API so that it will use it to do the test it needs to do and then give me a feedback. And so I'm using the post method, and you can see the data I am providing here. the data I am providing here. That is why I'm using the post method, and I'm setting it to body raw. I'm using the JSON format because the API needs to get the feedback in JSON to do the work. So that's just a brief different understanding of what the get and the post method do. If you are going to be feeding data, you use the post method. If you are just seeking to receive information without providing anything, you use the get method. Like I mentioned, there are other methods, but let's just stick to this for now. I'm not going to, I've noticed a few things. Without changing headache and the others, let's try to execute and see the result we get. Now, it is telling us unprocessable entity. Why? The reason is there are some features missing. Headache is missing, conversion is missing. The reason is because what we provided here does not tally with what the system is expecting. It does not tally with what our application is expecting, what our model is expecting. So it is important we address that. So all we need to do is to come back here and fix the data we are providing and make everything spelled properly, the same way our model was trained. Then anemia, jaundice, and then lastly prostration. So now that we have fixed all of this, I just provided a bit of information to it. Let us send it again and see what we get. Now you can see we now have a result with a status 200. A status 200 means it was successful. Our request was successful and we're getting a successful feedback. So it is now saying label severe malaria. Prediction, the result is 1. Now remember, from our data set, if you take a look, if you come back to our data set, let me quickly open it. The last column shows severe malaria. Severe malaria, if it is 0, it means it is not severe. If it is 1, it means it is severe. It means it is severe. Okay, so when we now have a prediction 1 here, which is, it means it is severe. That's why we have a label severe malaria. Then the severity risk is high. You can even see the probability 0.8, which is very close to 1. So that makes it really high. What if we were to modify a few things here? Let us take off rigor and make it 0. Let's set rigor to 0 and let's send again. You notice we have even a higher value right now. What if I take off, what if I reduce the age of the person to say 20 and send? Now it is still high, but not as high. So now I'm going to change the sex to female and send. Now you notice in the case of the female, the same age, the same data, the same symptoms, but the gender is the only thing that changed. The severity, though high, but it is lesser than when it was for male. Now, what I was able to understand from this is that there is apparently for some reasons, I believe these are part of the things we'll get to find out over time. For some reasons, for the same conditions, it tends to be more severe for men than for women. That is one. Another thing is, as a person advances in age, certain things may tend to become more severe. Now I just changed this age to 40, the same gender, everything. You can see the figure. So as a person grows advanced, grows older, it appears that the severity for a number of things tend to people need to what I'm just trying to say. Number one, two things. If you are a man, what this one tells me now, if you are a man, you need to be a lot more conscious of your health. You need to be a lot more conscious of your health. And I think it is part of even why if you take a look at World Health Organization, their predictions for life expectancy, it is actually higher for women than for men. What that means, as a man, you really have to be a lot more conscious of your health. Then as you grow older, you have to be a lot more conscious. Now I just reduced the age from 40 to age 10 for the same gender and every other thing. Notice the severity, the probability has dropped even further. So let us try the same age 10 for a male. You notice it has become higher. So this, what I was able to deduce from here is this: these are those two things. If you are a male, you need to be a lot more conscious of your health. Then as you grow older, you need also to be a lot more conscious. So now, and the same should also apply for younger children. So when you have, for parents amongst us, when you have children, you really need to be a lot more careful. You really need to pay a lot more attention to your kids, to the health of your kids. Prevent, since we are talking of mosquito here, try as much as possible to do everything in your power to prevent exposure to causes of malaria. So, having said that, just take a look at the stats, which is the last one I'll take a look at here. This also is a get because I'm not sending any data. I just want to receive information. So if I send, okay, it means there has been one error. If you remember, we had an error, and all the predictions, there's no one that has been not severe. All the times where all those that have been predicted were severe, and then the total number is 8. So 7 severe predictions and 1 error. Remember, we had an error before we now updated our headache conversion and the other parameters that we needed to present to our API. So I'm just going to go ahead to save all of this to be sure. So now, while I'm saving all of these, this allows me to easily export this postman, we call it a postman collection. I could easily just export it and share it with somebody else, and the person does not need to start imputing all the information, the URL, the data. Does not need to start imputing it. Just pick it up and can run from there. I believe developers amongst us especially, and those who work with us APIs day to day, would understand this, would understand where I'm coming from. So now, that is our training data and our app.py. Now, we've been able to achieve this. The next thing we now need to do, so I'm just going to stop that from running. So I'll do Control C on my keyboard here. It will stop. Let me clear so it becomes less messy. Now that I have stopped it, you discover if I try to run it again, I'll get connection reviews because the server is no longer running. The server is currently down. I've stopped the service from running. Okay, so the next thing we want to do is to take a look at our Streamlit app, where we now have the web application. Now, this was what we were presented to originally, which is just the core, and we're given a task to extend it. Let's quickly come back here. So to extend it to have these features: a sidebar, a request counter, color coded risk. So you have low in green, medium orange, and red in I, and then batch prediction. Batch prediction allows you to upload a complete data set and get the result without having to do it individually. So you can upload a CSV file, and then a sharp explanation panel. So the sharp explanation panel is basically to explain, whatever result you get, why did it give this result? Why did it give this result? Okay, so what I went ahead to do was to now build up on this. So, and at the end of the day, I arrived at this particular point. So this is where I arrived at. So the first thing, we have our all the packages we need to work with imported. Then I did a little bit of page configuration, having a page title, an icon, and the layout. How do I want it to be positioned on the screen? Then I set a default the major page, our main page. I put the header text there, the title for the main page. And then the next thing, to maintain what we have, we load from the cache, so that it doesn't have to run the model, it doesn't have to rerun the model every time. So we store it to cache, and then we brought in our pipeline. And then the next thing, the first task here, is to have our bar. So this brings in our sidebar and tells us information, the basic models that the basic features, the most important feature, the top 5 features for that gives us that is used to determine the result at the end of the day. Then we now have a prediction count telling us how many times it has run. Then which also has its own bit of a header. Then this is our main page. Our main page here, where we have the variables that we're working with. We have age, which is an input box. Then we have a gender, which is basically a drop down for male and female. Then the other features. So what I did here was to break it into 3 columns. So column 1 has fever to headache, the column 2 has bitter tongue to anemia, and column 3 has jaundice to this. Now, if we leave it this way, we are going to have an issue. And what will be our issue? We updated a few things on our model, on our original data set, which our model has been trained with. So we need to fix all of that here as well. So I'm going to first of all come here, fix headache, do same to convulsion so that it tallies with what we have in the original training. And then prostration, I'm going to fix prostration, okay, and jaundice also. Okay, so now that we have done that, we can come here and I can actually just go ahead with it, but since it has been updated, VS Code allows to just use this button to fix it. So when I click on this, it will fix all the parts that needs to be fixed. Okay, so headache has been fixed, but it appears convulsion isn't fixed. So let me just go ahead with fix the other one. Okay, so also yes, everything now has been fixed. So always remember to save whenever you make changes. Okay, then what we now do here, so I've talked about putting all of this into our column, so it's more like a tabular structure. It makes it, rather than having to scroll too far to see what we need to see. Then we have a button that whenever we click on the button, it will gather this information and then send it to the pipeline for the pipeline to make the predictions. And then it will update this count of the number of predictions that have been done on the for this particular session. And then it will, at the end of the day, it will show us the prediction result. And remember, it will give us, if it is 1, it will severe. If it is 0, if it is not 1, it is not severe. And then it will also, based on the probability, it will tell us low in green, medium in orange, or high in red. So we are using what we call the Streamlit Markdown, which allows us to bring in HTML, we bring in the background color and all of that. And then this is the sharp panel. So we are using the agnostic explainer, which is more like a waterfall pattern to explain exactly what happened, how the prediction, what the data we provided, how it was used to arrive at the desired result. And then lastly, the batch prediction part of it. So where we can upload a CSV file, and we must make sure the headers match with the data that we have, with the same way our what do we call it, our model has been trained. The column headers must match. If it doesn't match, it will result in an issue. So we upload it, it runs all of them, and then returns the result on the screen, which you can as well download the data. It returns the result on the screen, and then it gives us a button that allows us to export the data as another CSV file. So this is our Streamlit app. So in order to see this, I'm going to run a command on my browser, Streamlit run Streamlit underscore app.py. Okay, it has run and it opens up on my browser. It opens up on my browser, so just give it a few seconds. It will pop up. Now it is building. Okay, so this is our sidebar that we talked about. You can actually fold the sidebar and open it up. So the sidebar picks the five most important prediction features here: age, followed by headache, followed by convulsion, then bitter tongue, then jaundice. These are the top 5. Then we have our request counter here, and then we have our parameters we use. So these are the first part for parameter, and then this is the part for the batch upload, where we upload a CSV file. Okay, so if I'm by default, we have the age of 25, which I'm just going to leave. I'll leave it as female. Now I'm not going to select any of this. What it means is, if I select, it means I've set the value to 1. But if I don't select it, it means I leave it as 0. So if we come back to our Streamlit app, you will notice where all of those were actually set. You see fever equal to 1 if it is checked, but if it is not checked, it is 0. So that's exactly what that does. So I'm not going to check anything. I'll just go ahead to run. And so you can see prediction not severe, and you can see the background is green, risk level low. What if I now go okay? Then we now have our explanation of the prediction. So the explanation here is telling us, okay, so it used all of this information and what is the impact of each of these items. So you can see this is 0, this is 0, this is 0, this is 0. So everything points to 0. Everything points to 0. So at the end of the day, there is really no impact on what we are on the whole thing at the end of the day. So everything is 0. Yeah, so that is why with the severity is showing 0, is showing a 0 severity, so the risk is low. But if let's quickly I just want to do something funny. I'll select everything, set everything to 1, and then run the prediction again. Now it is saying it is medium. So now if you take a look at it here, we have quite a number of these as 1, and everything is actually set as 1, but the impact is not really so much at the end of the day. So we still have a risk level of 0. So if we were to change this to male, let us see if we have the same thing. Run prediction. You notice the difference now. So if you take a look at this now, everything is starting from point 1. Everything is starting from point 1, unlike the other one that was starting from 0. So now we're having a prediction severe, and the risk level is high with a probability of 81.6. Okay, and at the same time, if you check on the left here, you see the predictions made is now updated as 2, which on the norms is actually supposed to be 3, but because we just ran the last one, it is showing as 2. We have done 2 before the current one. Okay, so we have done this, and then let us try the batch upload. Now there's something we need to do, but let's even try it out before that. So I'm going to upload Malaria app. So I prepared test data. The test data is actually the same as our data set. I only removed the last column, which had to do with severity. I will show us that in a quick. Okay. Let me even show it to us before anything. So these are our test data. Age, fever is the exact same thing. So if you notice, I only removed the last column, which is talking of either severe or not severe malaria. The same data set, just for test purposes. So let's come back to our browser and open test data and we have an error. Why? We have not updated our columns. The columns do not match. So to fix that, let us first of all close this and then come back to our VS Code and fix the headers. So let's start by fixing headache, convulsion, anemia, jaundice, and prostration. And then go ahead to save. We can close this one now, and let's come back to our browser and upload the data again. Now it has run, and you can see the result, and at the end you can see it has a probability, prediction, probability, and a risk. It has 3 columns added now: prediction, probability, and the risk involved. We can decide to pick columns we want to view and the ones we don't want to view. We can enlarge it and see it in full screen view, and we can reduce it as well. We can download the table as a CSV. We can export it as CSV, and we can, from here, we can also download the result as CSV. So it downloads it as CSV. So we can open folder and then just open it. Let me try see if I can open it with VS Code again. So that's our prediction VS Code. So prediction, probability, and the risk level. So it has done the prediction for all of these, all the rows we uploaded at a go. Okay, so everything I have done here is done locally on my computer. Everything I've done here is done locally on my computer. You can see our prediction count has been updated. It's done locally on my computer. The next thing would be to think of, okay, let us start talking of deploying it to a live environment that makes it accessible. So the first thing would be to take a look at our Docker file and see what we did. So the first thing I'm doing here, I'm not going to really make any changes. The only changes I'm making to my Docker file is just to, initially it was Python 3.11, but I'm using Python 3.13 on my PC. So that's why I updated it to 3.13 here. Every other thing here works for me. The only other thing I did was to change the port. It was initially port 5000, and I mentioned to you earlier that another application is already using that port. So I simply changed it to port 3100. So I could as well decide to change it to a different port so that it doesn't clash with, even if I want to do things locally, but I'm going to leave it as this. Now, it is also another point we need to understand is this file requirements.txt. This is where one part that gave me a bit of issue until I had to find a way to understand what the issue was. So if you take a look at requirement.txt, now if you look at what we are given originally, you will notice I'm using different versions from what we were provided originally. Now it is important to ensure that whatever version of these packages you are using, it must tally with the one that was used to train the data. Now, what I had to do before I even went into all of this, I had to actually execute each of these code, each of these stuff one after the other in a Jupyter notebook. So I actually executed all of this step by step. So the training and all of that. But where I'm going to is the last part here. So I had to run this to understand, so I can know the exact version of these packages that are running on my PC, that were, or do I say that were used, that was used to train the data. I'm just going to zoom in a little bit. So I had to get this to get the exact version, and so I got the exact version from this. So when I got the exact version, I simply did what I just did, simply copy. I copied this, and then after copying, I just replaced everything inside the requirements.txt. After replacing the requirement.txt, I simply went ahead to execute, to build the Docker uh, to build the Docker app. So let me stop. To build the Docker app, you simply do you should check this document. You would see that on your, it's there, but let me quickly, I should have it rather than me having to type everything. Okay, so this is what I had to do. So this is it. So the no catch is not compulsory. So you build the app. So by the time, if I come over to my Docker now, that is the app that was built here. So you can view the details of the container. You can view. So I was able to build it. After building it and serve it, and then I went ahead to start to just test out a few things. So I previously built it, so all I need to do for me now is basically just to run it. But because of the changes that we made to our data, it may be important to just have to rebuild this afresh. It is important to rebuild it afresh, but I'm not going to be doing that right now. It may take a little bit of a time. Okay, so coming back to our code, the next thing I had to do now was to put everything together and push it to GitHub. Okay, because now it's showing this because I stopped the app. I had to stop it. You can see when I stopped it. So I stopped it, so that's why it's no longer accessible here. So I uploaded everything to GitHub. So this is it to GitHub, the training data and all of this. I uploaded everything to GitHub, and then I went. Note that what I uploaded here now is not even the update that we did. So to fix all of this, I may need to actually update the file, but I'm just going to stick to it for now. I'll be doing that later after this session. So this is our training.py file. So all of this has been uploaded to GitHub. Then after uploading to GitHub, I came over to render, and then following the steps in the that we are provided with, I created and I pushed to render. So if you come over, so this is the URL for the base URL for my render app. So if I come back to Postman, you will see where I have live earth. You can see the base URL on the screen, which is the one from render. So if I execute this, I'm expecting to see a positive result. Now you will notice it is taking a bit of a time. Now let me tell you why it is doing this. Is because even render will even tell you, you see your free instance will spin down with inactivity, which can delay requests by 50 seconds or more. So since I've not called this endpoint for a while, it will take some time for it to spin up again, because it is a free account on render, which at this point is very okay for us. But after the first time that it took time, if I were to execute this again, it will return very fast. Right, to get info, it will come very fast. So you will notice it is very simple. It is until for me to get the updated one, I have to go update everything on GitHub and then do basically a rebuild of everything that we have here. So that is our API on render. Then the next thing is now the Streamlit app. So once again, I came over to Streamlit, and following the steps, I created the application, and it's very easy to do, very easy to do. Click from the GitHub, just connect your repo and tell it where you want it to start from. That's basically it, and then you choose the URL you want. So I did that, and then this is my app. So if I click on this, that is it on Streamline. So with this URL, I can make it available to anybody, and they can go ahead to test it out on their own and also see. So that is basically what, so this is what I've been able to achieve following the guidelines, and also doing a bit of research to understand a few things better, and also to make so that so like I will always say, we are constantly in a learning phase. We are constantly in a learning phase, and it just takes the willingness to learn and practice and put in the work. That's basically put in the work, and over time we get better. So I was discussing with one of our colleagues earlier today, and we are already thinking of, wow, if we can get something like this for malaria, let us see how we can pick up another kind of ailment and see if we can even infuse it into what we have. So we have for malaria, we have for another one. If we can make it even within a single app or a different app, or find a way to put all of them, link all of them together. So these are things that I believe if we work together as a team, we'll be able to get it. So at this point, I'm going to say thank you, everyone, and we'll just keep getting better. Thanks, everyone.